Okay, so here's kind of what we had yesterday. Take a quick look here. We had something like this. Was this 8 miles downstream? Six. Six. All right, so here's what we said. Remember, what we'd come to the conclusion, and this is, I'll just say a couple more things about this. We'll wrap it up and we'll get you down there. We had to come up with a cost formula. We're minimizing cost, right? And the cost, the way we would think about this is what we would call in math a weighted distance. Because what it's really related to is distance, right? But we're not actually trying to minimize distance because the distance is weighted in the sense that some of the distance costs more than the other distance, right? And so it's the shortest path between the start and the end is probably not going to be the answer. We're going to want to instead make that green expensive distance a little bit shorter, right? And when we weight something in math, that means we're going to multiply it by a coefficient. And so what we ended up saying was, that CW, the cost on the water, was 16, and there's the weighting factor, there's the coefficient, because that's the cost per foot or something like that, right? Times that distance, which we calculated in terms of x. Remember, that was 1/2. We did all the math, and we got this. Right, there's the distance times the weight, cost per mile, or per foot. We said cost on the land was a little simpler. That was just the weight of 12 times the distance, 6 minus x. What we came up with then was an answer like C of x equals 16 times the quantity x squared plus 1/4 to the 1/2, right? We want to write it as a fractional exponent so we can differentiate. Plus, if we distribute the 12, 72 minus 6x, and then I think we had just gotten to the place where we had taken the derivative, or we were in the, it's like we did. We finished that. Okay, so we got c prime of x, and then we used the chain rule here, multiplied the 1/2 times the 16 and got 8 times x squared plus 1/4 to the minus 1/2, right? Times the derivative of what's inside, which was our 2x. And then over here we just got a minus 6. Did I mess something up?
It'd be 12x.
Oh, you're right. Whoops, you're right. I don't know how I got 6. Oh, I see how I got 6. Yeah. There we go. And I think that's where we left off. Thank you. And we had our domain went from 0 to 6, right? We said also. And now we're gonna find the critical numbers. Well, this thing we said equaled 0 when. Well, let me tell you what, let's rewrite this. So we end up with, if I write this as a fraction, 8 times 2x is 16x. This goes to the bottom, right, because it's a negative exponent over the square root of x squared plus 1/4 minus 12. Okay, now that's our derivative, written in maybe simplified form. Is that undefined any place? Okay, where the bottom equals 0. Now look at the argument of that square root, x squared plus 1/4. Can that ever equal 0? Okay, so we're okay there, aren't we? We're only going to get critical numbers where this thing is equal to 0. And it equals 0 at this equals 12, right?
Yeah.
Okay, so 16x over the square root of x squared plus 1/4 equals 12. And now we just have to solve a radical equation, which is good practice. So we would probably just cross multiply, right, to get rid of the fractions, and get 12 times the square root of x squared plus 1/4 equals 16x. Good. Divide each side by, what, 4? Okay. And let's go ahead. I'm going to run out. Oh, man. I'm going to run out of space here. So how about if we do this? Okay. And then if I divide both sides by 4, I'm just going to get 3 times the square root of x squared plus 1/4 equals 4x. Now what? What's our rule when we're solving a radical equation? Say it again. Can't divide away variables. That's true. But if I'm going to solve an equation involving radicals, remember that I have to get rid of the radical, because I can't really do the algebra of the radical. It's pretty difficult. Right, all this stuff is trapped inside this function, so I want to try to undo that function. Okay, I can square both sides. I'm going to isolate the radical. Remember that? Isolate the radical, and then take both sides to the appropriate power to get rid of the radical. Right? So in this case, I could divide each side through by 3 and get the square root of x squared plus 1/4 equals 4/3 x. Right, or 4x over 3. And now I'm going to square both sides to get rid of that radical. But you got to be careful. If I take both sides to an even power like this, what might I be doing? Well, okay, it's kind of like that. It's kind of like the idea of a plus or minus. It's related to that. But I might be introducing extraneous solutions. So it means that there may be some additional mathematical solutions that are introduced that don't apply to this problem. Exactly. So when we're all done, we have to just go back to the step before we square both sides and see if the solutions actually do work. Right? Now, this is why everybody should have a smartboard in their rooms at home and a portable one that they carry around, so you can just change colors like this to remind yourself that we just did something, big. We just squared both sides. And so this side is going to become x squared plus 1/4. And this side is going to become 16x squared over 9, right? Make sense? Okay. And now, maybe actually, in hindsight, even though this is kind of following the rules that we did in Algebra 2 and pre-calculus, maybe I didn't need to I could have left that 3 there, and when I squared this side, I would have just ended up with a 9 out front. Because I'm probably going to do that now anyway. I might as well clear the fractions, right? Is that right? Yeah, exactly. So if I multiply both sides by 9, I'd get 9x squared plus 9/4 equals 16x squared. Now to solve for x, what do I do?
7x squared.
Yeah, that makes sense. I'll subtract 9x squared. 9/4 equals 16/9. No, sorry, 7x squared. What am I doing? My goodness. It's early. Equals 7x squared. Divide by 7, so 9/28. Does that make sense? So x equals plus or minus. What's that going to be? Square root, and I just leave it as square root of 9/28. That's an exact answer. Right. If we plug that back in to see if it works now, let's see. It's almost easy. Well, that's fine. So I'm going to get the square root of 9/28 plus 1/4 would be 16/28, right? equals, so on this side I'm going to get square root of 16/28 equals 4/3 times the square root of 9/28. Is that right? Oh, no, it's not. Gosh darn it, I messed that up, didn't I? Oh. I'll go back. I'm trying to do too much of this. I got it. It's 9/28 squared, isn't it? Right. So I'd have to say, oh my God, that's huge. Yikes. So that's going to be what? 81. What? Something enormous. If I plug this number, I got to take this square root of this, right? I got to take the positive one and plug it back in there to see if it works. Right. So x squared is that. It's 920. Oh, actually, no, it's just 9/28. Never mind. So I was doing it right. So it'd be, what did I have there again? 9/28 plus 1 plus 7/28 is 16/28. Okay, I was on the right track. Equals, is that the same thing as 4/3 times the square root of 9/28? It's not, is it? Thank you. I'll give these guys so what the heck?
Oh, no, it is the same.
It is the same?
Yeah.
Okay, so it checks out. Yes. So it works, right? So the solution that we got when we solved this equation by squaring both sides, when I plug the positive one back in, it makes the equation prior to squaring work. So it's a solution, right? And so that's our one critical number. Now probably we're just going to make it a decimal, round it as a decimal. So what is that as a decimal? 0.756. If we took it out to 3 places, that's probably good enough. If we took it out to 3 places, then we could make our table, right, real quick, and we know what's going to happen. Just go, looks like x, what do we call this thing, cost, c prime. Our domain went from 0 to 6. The one critical number we got was, what was it again, 0.756? Gave us a 0 of the first derivative. If I don't want to take a second derivative, do I? This is an ugly one, because I've got square roots in it. Make sense? Yeah. So we could just go back and just pick some test points. So if this is c prime of x, what if I put in 0? What am I going to, I'm going to get back negative. Agreed? So c prime of 0 is negative. What about c prime of 6, the other end? That's gonna give us something positive, isn't it? Okay, I'm gonna get square root of something roughly like 6 over something really big. So yeah, that's gonna give us something positive. We could check it, but it will. And so then we know that it's doing what? It's going from negative to positive. That's our minimum, right? Okay. That's kind of, I mean, because those numbers are so weird, that was kind of a strange one. But that happens in real life, and they don't always work out to be nice numbers. Okay. Does that make sense?
Yes.
Okay. All right. So that's where we aim. That is a good problem.